Today's lesson is on parent functions, and we're going to talk about 6 basic parent functions today: linear, absolute value, quadratic, cubic, cube root, and square root. You will be able to look at an equation and identify what the shape is going to look like, and you will also be able to create a table of values that are appropriate for each function. All right, the most basic function, the one that you are familiar with, is the linear function. And a linear function is just a line as it has in the equation, or in the name rather. The equation is y equals x, and that x, by the way, is to the first power. That's going to be important. We know the line is just going to look like this, but to get a more accurate line, we are going to create a table of values. When we're choosing a table of values for a line, there are no restrictions on our domain, so we can choose any positive and any negative numbers. For that reason, we are going to choose -2, -1, 0, 1, and 2, the smallest, most basic numbers. Now, that's what I'm choosing for the x value. If I take my equation y equals x and I plug in -2, you're going to see if x is -2, then y has to equal -2. If x is -1, y has to equal -1, and so on. And when you plot those points, you are going to get 0, 0, 1, 1, 2, 2, 3, 3, continuing down, and then -1, -1, -2, -2, so on. And you are going to get this right here. The domain on this is all real numbers. It goes from -infinity to +infinity. I'm not going to talk about the range today, only the domain. Absolute value. What you know of absolute value is that it makes the function positive. You also know the symbol for absolute value are just two lines that look like this. You also know that x can be any number here, negative or positive. So we can therefore, for our x values, choose any negative and positive numbers. So the smallest ones that we can choose, that we will choose, are -2 to +2, just like with a linear function. Now, the difference though is when we plug in a value in here, say we plug in -2, when we take the absolute value of that, we get +2. We know a -1 gives us +1, 0, 0, the absolute value is 1, and 2 is 2. When I plot these, I'm going to get -2, +2, -1, +1, 0, 0, 1, 1, 2, 2. And look what happens. It is V-shaped. So this right here is a V-shaped graph, and every time it's absolute value, it will have an absolute value symbol in there with the two lines around it like we have right here. The domain on this is -infinity to +infinity. There are no restrictions on the domain. We could have chosen any x values here, just as we could with our linear function. An absolute value, like we had here, you know it's going to be an absolute value. That is the family. Now, hopefully what you know of a quadratic function is that is U-shaped like this. All quadratics will be U-shaped. Hopefully you also know that it has an x squared. The parent function, or the most basic function, is y equals x squared. Nothing is added or subtracted or multiplied to that. You also should know that you can have any x value right here. There are no restrictions on the domain. So for that reason, I'm just going to choose -2, -1, 0, 1, and 2. Because I can take any number inside the x and square it. So when I take -2, the first x value I've chosen, I have to put parentheses around it, and when I square that, I get a +4. When I take -1 and square that, I'm going to get a +1. 0 squared is 0, 1 squared is 1, 2 squared is 4. And if I plot these points, I have -2, +4. I have -1, 1, 0, 0, 1, 1, and 2, 4. And there's my U-shaped parabola. These parent functions that I'm drawing are the most basic functions in the family of functions that we're talking about. So when you're graphing these, when we start transformations with this, you're going to have to not only know the values to create this table, so you're going to have to know which x values to choose, you are also going to have to be able to identify what type of which family function it is by looking at the equation. So every time you see an x squared, you know that that's going to be quadratic. Every time you see that we are talking about. Now all those were review. Here's our first new one, a cubic function. Cubic. Cubic means to the third power. So anytime you see cubic, you should have something that goes to the third power. It is being cubed, therefore it is cubic. So anything to the third power is to the cubic function family. And again, there are no restrictions on the domain here, so we can choose -2, -1, 0, 1, and 2, because we can take any single number in the whole world and take it to the third power. Now when I'm doing -2 and I take that to the third power, if I would plug that in my calculator, I would get -8. If I took -1 to the third power, that's a -1 times -1 times -1. I'm going to get -1 back. 0 is 0, 1 is 1, and if I take 2 to the third power, I'm going to get a +8. I'm going to plot these points and we'll see what kind of shape we get. So I have -2, -8, -1, -1. 0, 0, 1, 1, and 2, 8. This is my function here, and what you need to make sure you do is that you have, it sort of looks like half a parabola opening up here, it's curved, and half the parabola opens down like that. So anytime you have a cubic function, it is going to hold this shape. Of course, we're going to apply transformations, but it is sort of like this silly snake shape or S-shaped. And it will always have a third power to it. So third power is going to be cubic, and again, it'll hold that shape. And you, again, have no restrictions on the domain, so you choose from -2 to +2. Here, it looks similar to the cubic function, but this goes up and down, and look at that cube root function. Okay, the root functions, square root and cube root. You know a square root looks like this, and it's y equals the square root of x. That is the most basic function in a family of functions. Anytime you see a square root right here, you will say that is part of the square root family. And we'll see what that looks like here when we graph it in just a minute. When you have a cube root function, it's going to be very similar, except for instead of the square root, it's going to be a cube root to the third, 1/3 right here, cube. So when we graph these two, we have to be really careful on the values we choose, because if I try to choose a negative value here, say I choose -2, and I plug that into my calculator, what I'm going to get is an error message. And we know from Algebra 2, because a negative under the radical introduces an I. This is the same as I times the square root of 2. We don't want to deal with imaginary numbers on our graphs, so we are not going to choose negative values. So with square roots, we cannot have negatives. So no negative x values when we choose them. So instead, we have to choose only positive. So we have to start with 0. 0 and 1 are always going to be used in all of these functions. But the next three values are not going to be 2, 3, and 4, because for this portion of your test, you will not have a calculator. And if I ask you what the square root of 2 is because you choose the value of x equals 2, you won't know without a calculator. If I ask you the square root of 3, you don't know without a calculator. But if I ask you the square root of 4, you know that that is equal to 2. So I'm going to choose the x value of 4 because I know the square root of 4 is equal to 2. Now I have to choose another number. Square root of 5, I don't know that. Square root of 6, I can go on and on, but the next one I'm going to choose is 9, because what I'm looking for right here are perfect squares. These are all perfect squares, 1, 4, and 9. The square root of 9 is equal to 3. The square root of 1 is equal to 1, and square root of 0 is equal to 0. So that's what my y values are there. Now look what happens when I graph this. I have 0, 0, 1, 1, 4, 2, and 9, 3. And notice I didn't go any further. I left that one blank because 9 is already going to be off my graph. And look what happens. It stops right here, or rather it starts there, and it goes up and over with a slight incline like that. That will take place with every square root function every time you have a square root like that. Cube root functions are very similar, except for we can have negatives now, because if you take in the third root, you have that function in your calculator. If you take the third root of any number, let's say -2, and you plug that in your calculator, you will get an answer. What you get here is approximately -1.259, blah, blah, blah. Okay, now I needed a calculator to get that answer, so I'm not going to choose the value of -2, but I do know I can choose negatives. What I need to choose are perfect cubes, because I'm looking at a cube root, but I need perfect cubes. So if you don't know what perfect cubes are, if you take 0 and you multiply it by itself 3 times, you get 0. If you take 1 and multiply it by itself 3 times, you get 1. These are perfect cubes. If you do that with 2, you get 8. 8 is a perfect cube. We'll use that number. And I could continue on and do 3, but that gives me 27, and that's way off my graph, so I'm not going to do that. So what I'm going to choose for x values are going to be those perfect cubes right here. So I'm going to choose 0, and then I'm going to choose the perfect cube of 1 and the perfect cube of 8. Now I'm going to put 0 in the middle here, and I know 0 goes with 0, because if I plug in my calculator the third root of 0, then I get 0. And I am going to choose -1 and -8 because I know these are my perfect cubes right here, and I need positives and negatives. So not only do I choose the positive values here, but I just choose the negatives that correspond with it. And I know, because I did the math right here, that this is going to give me 2 if I take and plug in my calculator the third root of 8. And those of you that had the big calculator, it's under the math button. If you go under math, you can see there's a third root somewhere on there, and you can plug that in and then hit 8. In the small calculators, you know you have that function, I think, well, somewhere on there. But you should have a big calculator now anyway. And if I do the third root of 1, I get 1, that number there. And this right here is going to give me -1, and that's going to give me -2. And before we graph this, take a look at this. There we have our values, -1, 0, 1, and 2. Look what we have here, 0, 1, 2, 3, because we couldn't choose negatives. Okay, so pay attention to that. That's what you should get over there. Now, when I graph this, I'm going to get -8, -2, -1, 1, 0, 0, 1, 1, 8, 2. Now I have this nice curve right here, and again it looks similar to just goes to the right and to the left. Also notice it looks similar to the square root function, because look at that square root, that third root, very similar. This one just went up and to the right, and this one not only goes up and to the right, it also goes down and to the and back. Okay, and again, you won't have your calculator on this portion of your test, so you have to know what these functions are and what the sketch is going to look like of the graph, and also what the table is going to look like. And both of these, not both of these, the top one has restrictions on the domain, because the restrictions on the domain right here is just going to go from 0 to infinity. Okay, if there's no transformations, it actually includes 0, so that should have brackets. But the domain on this bottom one is -infinity to infinity. And sorry, this is getting a little bit messy here. So we talked about the 6 basic parent functions, and there are 2 functions that have restrictions on the domain. So the square root function, which is the last one that we just did, so anything that has a square root, can only be positive. Only positive, okay? There's another function also, and I'm just going to sketch here. It looks like this, up and over, just as a reminder. and I'll write the domain as 0 to infinity. Okay, only positive values can be for the x. There's another function called the reciprocal function. It's also called the rational function. And what that is that's a fraction. So y equals 1 over x. And this is a special one because it looks different. It has two parts. It actually has a part that's right here, like this, and a part that's right here, like this. And what's happening right here, I'm going to put this dotted line right here, and I'm going to put this dotted line right here. And what we have there are vertical and horizontal asymptotes and horizontal. And we're going to talk more about those later. And the reason I'm telling you about this now is because I want to talk about these restrictions on the domain, because you know that whenever you have a fraction that you cannot take and divide by 0. 1 divided by 0 does not exist. So this right here cannot be equal to 0. This is going to come into play here in a little bit, but that's super important. You're not going to deal with it today. But what this domain would be, it's all real numbers except for 0, because it's never going to cross or touch this line. That's what a vertical asymptote is. The function gets really, really close to it right here and really, really close to it down here, and also over here and down here, but it never crosses or touches. And again, we'll talk more about that later. And you won't have to graph any of those right now. Okay, so now that you have all the basics, here's what we're going to do. We're going to name and sketch the parent function, as well as create the table of values in which we would use the x table of values. So what you're going to do is this. You're going to take a look at the function, and you're going to look to see what right here is happening with it. This happens to be a square root. This is therefore the part of the square root family of functions. So this one is a square root. And then you're going to sketch it. So then you have to ask yourself, okay, what does a square root function look like? A square root function looks like this. It goes up and over like this. So you're just going to do a quick sketch. Even if you just do it like this without a coordinate plane, that is fine. Then the other thing that I want you to do is create the table of x values that you have. So you have to ask yourself, are there restrictions on the square root function? And yes, there are. These have to be positive. So have to be positive. So you cannot choose any negatives. So your first value is 0. You also want to choose the perfect squares. 0 and 1 will always be a value for all of these except rational, which we're not graphing. But now we want the perfect squares. So we want to choose 4 because that's the next perfect square. And then we want to choose 9 because that's the next perfect square. Don't worry about filling in any of those other values right now. Then if we take a look at the next one is a cube. It has a cube, therefore this is a cubic family. And what that looks like is it's sort of, remember that combination of a squared, x squared, remember, is that parabola? It's sort of like that, except for half of it goes up and half of it goes down. It's sort of that snake shape one. And as far as the table of values, you have no restrictions on the domain. It can be positive or negative. So it's -2, -1, 0, 1, and 2. Now try to do all of this without looking at your sheet, because you need to memorize this, because again, you won't have a calculator for your test, and this is where you will start with all of yours. When you look at the next one, you're going to look to see what's happening with the x, and it's a cube root. So this is a cube root, therefore this is part of the cube root family of functions. A cube root looks similar to a cubic with that 3 and that 3, except for it is kind of flipped on its side. So it goes up and over and down and back like that. The table of values, when we're choosing those, we can have positives and we can have negatives. Square root's the only one we can't, but we want to have perfect cubes. So we are going to choose -8, -1, 0, 1, and 8. Perfect cubes. Again, 0 and 1 are always them, so really you only have to remember the 8, 2 times 2 times 2. Okay, let's look at a few more, and then I'll let you pause it and work on some on your own. This one right here has an absolute value. So what is the family function called? Absolute value. And absolute value do not, shape of it first. The shape of the absolute value is V-shaped. So it's going to look like this. There are no restrictions on the domain, so you can choose -2 to +2. The next one has a cube root. So this is a cubic family. And this is where you choose perfect cubes. So your x values, you can choose positive and negative, but they have to be perfect cubes. We'll always choose 0 and 1. The next one is 2 times 2 times 2, or 8. And then we have the negatives that go with it. The last one on this page is the one people mess up the most because it has a squared, and it's not called the squared family. Do not write that. This is the quadratic. It's the only one that has a different name than the mathematical operation that's in it. So this is the quadratic family. There are no restrictions on the domain, so -2, -1, 0, 1, and 2. We do not have to pick anything special, only if it were square root or cube root. All right, you should pause the video on this, name and sketch the parent function, and also sketch the table, the x values of what you would choose for the parent function. And this is what you should have. You have a cubic versus a cube root. The cube root right here is the only one that has special values because in order to evaluate a cube root without your calculator, you want perfect cubes. And then the last one is an absolute value, V-shaped. And you should now pause the video and give these ones a try really quick. Sketch them, name the family of function, create the coordinate plane, and check to see if your answers are correct when you're done. And there you have it. You have a cubic absolute value and cube root. The only one that has special x values are the cube root because we can have negatives, but we want perfect cubes, so we can do that in our head. All right, so that's it for today. What you're going to do is on your 1.6 worksheet, you are not going to complete the whole thing. You're not going to graph the whole thing. What you're going to do is you're going to name the family function and sketch the parent function. So in the family function part, you're going to write whatever name it is, and then off to the side of that, you're going to have the sketch of what that is. You also will go through, it doesn't say this, but you will do this. You will fill out the XY table, the X values that you will choose, just like we did on the examples. So -2 to +2, or if you need the special values of perfect cubes or perfect squares, and the positives versus negatives. So do that throughout your worksheet. That is your only assignment for today. And we'll come back and work more on that worksheet tomorrow. Bye.